Think about the world around us for a second. From the car you drive to the food on your table, pretty much everything is built by these incredible automated systems. But behind all the whirring robotic arms and conveyor belts, there's a hidden intelligence, a brain, that's making it all happen. So let's pull back the curtain and look at the tech that's powering modern industry.
What we're seeing now is the rise of the factory of the future. And look, this isn't just about robots doing the same simple thing over and over again. The real leap forward is the shift to these intelligent, totally integrated systems that can actually learn, adapt, and make their own decisions. So that leads to the big question, right? What is the secret sauce here? What's the hidden brain that's actually conducting this whole symphony?
Well, that's exactly what we're going to get into. In this first part, we're going to meet the brain of this future factory.
It's called an industrial controller. And honestly, the analogies here are just perfect. Think of it as the central nervous system of the entire plant, sending signals and coordinating every single movement. Or, if you like, it's the conductor of an automated orchestra, making sure every machine, every motor, every valve plays its part at the exact right moment. It's the thing that regulates, manages, and optimizes the whole show.
Okay, so we know what it is. But now for the really cool part, how do these things actually, well, think and act?
It all boils down to this constant four-step cycle. First, it has to sense what's going on using sensors, maybe measuring the temperature. Second, it decides. It compares that temperature to the ideal temperature, what they call the set point. Third, it acts. It sends a command to, say, a heater to make an adjustment. And fourth, and this is absolutely crucial, it gets feedback to confirm the action worked. It's this never-ending loop of sense, decide, act, and then check your work.
And this really gets to the heart of two different ways of thinking about control. On one side, you've got open-loop control. This system basically runs on trust. It sends out a command and just hopes it was carried out perfectly. It's simpler, sure, and cheaper. But then you have closed-loop control. This is all about trust but verify. It uses that feedback step we just talked about to constantly check and correct itself. It's the difference between telling someone walk 10 steps forward and just turning away versus watching them and saying, a little to the left, okay, perfect.
So how important is that verify approach? Well, by 2025, closed-loop systems are on track to make up about 80% of the market. And why? It's simple. Modern manufacturing, whether it's building EVs or making medicine, demands a level of precision you can only get when you are constantly double-checking your work.
But of course, not every task is created equal. You wouldn't use a sledgehammer to hang a tiny picture frame, right? Same idea here. There's a different kind of controller for just about every job you can imagine.
Now, one really important thing you gotta know before we dive into the types, today the lines between them are getting super blurry. Lots of modern controllers are hybrids, but to really get it, you have to understand where they each came from, the specific problem they were born to solve. And this table just lays it out perfectly. First, you have the PLC, the Programmable Logic Controller. This is the workhorse for doing one thing over and over. It's like a dedicated boss for a single machine. Then there's the DCS, or Distributed Control System. This thing is the CEO of an entire plant, managing massive continuous processes like in an oil refinery. A PAC is a powerful hybrid. Think of it as that machine boss who also happens to be a data scientist, handling complex control and heavy data. And finally, you've got SCADA systems, which are like the air traffic controllers for things spread out over huge areas, like a city's power grid.
All right, so we've got the tech down. Now let's talk about the companies, the major players who are really shaping this entire industry. These are the titans of automation.
But first, this quote right here, it hits the nail on the head. Picking a controller is not like buying a single piece of hardware. It's a long-term commitment. You are marrying an entire ecosystem of software, support, and future technology from that one vendor. It's a massive strategic decision.
And here are some of the heavy hitters. You've got giants like Siemens who are all in on creating digital twins, complete virtual copies of entire factories. There's Rockwell Automation with its Factory Talk platform, trying to make AI easy for everyone to use. ABB is a powerhouse in robotics and electrification, and Schneider Electric's EcoStruxure platform is laser-focused on energy management and sustainability. See, they're all competing on these huge, all-encompassing digital platforms.
And that brings us to our final section, because this story is far from over. Right now, we're in the middle of a full-blown intelligence revolution that's changing what these controllers can even do.
This is where things get really cool. Thanks to what's called the Industrial Internet of Things, or IIoT, and AI, these controllers are becoming geniuses. They can now do predictive maintenance.
analyzing data to fix a machine before it breaks. They're the engine behind those digital twins we mentioned, where you can test out new ideas in a virtual world with zero risk. AI is also letting these systems teach themselves how to get better, faster, and more efficient. And with edge computing, the thinking happens right there at the machine, allowing for the split-second decisions that true, real-time control requires.
So what does all this mean in the real world? Well, let's just take predictive maintenance. That one trend alone can slash unplanned downtime in a factory by up to 50%. That is an absolute game changer, boosting productivity and the bottom line.
Which leaves us with one last big question to think about. We've seen how these industrial brains are evolving from just following orders to actually learning and adapting on their own. So, as they get smarter and take on even more complex work, what does that mean for the future of human jobs in this new world of manufacturing?